This rooted phylogenetic tree was created using different types of pins that I found around my home. The pins are arranged based on their relationship with a common ancestor. Looking at how the pins are categorized, the bobby pin is considered the outgroup because the operational taxonomic unit that distinguishes it from the other pins are the rounded ends of the pins. All the other pins have pointed ends. The pointed pins are then further characterized by what material they are used with. Pins circled in purple have the OTU that they are used on fabric, whereas the pins circled in orange are used on cork. The next grouping of pins arises from cladogenesis, and the pins are grouped based on their utility. Sewing pins are circled in red, and decorational pins are circled in pink. Sewing pins are again categorized using cladogenesis. The first OTU distinguishes the pins based on whether or not they are safety pins. The second OTU distinguishes non-safety pins by color. Decorative fabric pins are also characterized into OTU by color. The corkboard pins are first grouped by shape, with the owl pin being the only member of its OTU. The classic push pins are then further divided based on whether they are colored or clear. The clear push pin is in an OTU of its own. The colored push pin circled in blue represents anagenesis because the OTU distinguishes a pin covered in colored tape as a colored pin. However, after attaining color for corkboard pins, I no longer need to cover clear ones in tape. The final OTU arises from cladogenesis and divides the colored plastic push pins by color. The internal node labeled with the number 1 represents the most common ancestor of all the pins. The internal node labeled with the number 2 indicates the most common ancestor of just the pointed pins. This diagram simply shows the tree written out in words.